Okay, let's go. Hi, I'm Ellie,
I'm Korody.
I'm Eduardo Ortega.
and we had problem number 4.
So the first part of problem number 4, part A, is asking to find the impedance of the system. Now to find the impedance of the
It's
system,
impedance.
to find the impedance of the system, you're going to take this equation, Z, and you have to set it equal to the square root of R squared plus, because it's only an inductor, it's only going to be the reactance of L. So take that X sub L, square that, and that is how you find the impedance. And then from there, from this, you can go to part B, which is asking the amplitude of the voltage. Now, we always know the equation of delta V is going to be equal to current times by resistance. So from here, actually, the total amount of impedance is going to substitute for resistance. So instead of R, we can substitute that in with C. So from here, we can single out current max to get the amplitude of the current. So current max is going to be delta V max over Z. And in terms of the whole equation itself, delta V is going to be equal to V naught sine omega t. But when you divide out the Z on both sides, that V naught over Z becomes that I max. And that delta V relative to T over Z is going to be the equation for current in the whole system. But it is more important to note that the V naught over Z, or delta V max over Z, is going to be the amplitude of the current.
Our next goal is to find the amplitude. We have two equations, delta V max equals IR for the resistor, and delta V max equals IL for the inductor. We can sub in angular frequency and length and set them equal to each other because we're looking at the max in both locations. We get I max R equals I max WL. Angular frequency is resistance over the inductor.
So for the last 2 problems, we are going to use impedance in order to find what the conditions are going to be when the voltage is towards one side or the other. So to do this, we're going to look at angular frequency, and in the first problem they ask what would happen if the angular frequency was really large. And so the only place where angular frequency occurs in impedance is going to be the X over L value. So if X over L value is very large, the impedance value does not change. Therefore, the R value is going to go essentially to 0. And so we have Z is going to equal X sub L. And so when we have all the impedance just in the inductor, that means that the V max, which also equals the V naught, is going to be all in the inductor. So in other words, there's no voltage in the resistor, and all the voltage is in the inductor. For the second problem, the angular frequency is going to go to essentially 0, or going to be very small. And so this value in the impedance is going to go to 0. So the impedance is essentially going to equal R. Therefore, all the voltage is going to be in the resistor and no voltage is going to be in the inductor. So we have V equals 0 in the inductor. That's our problem.
I love physics.